Here we are with lesson 3.5, starting on page 159. And this is, we're only going to do a part A because I'm not going to do this whole lesson, okay? We're just going to do this first page. And this is multiplying a binomial by a trinomial. And so blah, blah. This is a word problem. A rectangle has length 5x plus 2 and width x squared plus 2x plus 1 centimeters. Find the area by completing these solutions. So the area equals length times width. Length is 5x plus 2 and width is x squared plus 2x plus 1. And we're to do it using a diagram and then use the distributive property. So we've got, let's do the diagram. I'm going to do the three terms across the top because it's more space. So x squared plus 2x and 1. So split that up like that. And then down the side, I'm going to do 5x and 2. So this square gets 5x squared. This gets 10x squared. This gets 5x. This is 2. Oops, this was supposed to be cubed. I'm sorry. This is 2x squared. This is 4x, and this is 2. So my sum is going to be 5x cubed plus 12x squared plus 9x plus 2. Okay, let's do this using the distributive property. So remember our basic thing is everything in the first brackets times everything in the second brackets. And they've actually broken that up for you. I've never actually seen it written like this, but this makes sense. I'm going to kind of ignore that though, and I'm just going to do the distribution the way we would normally write it, because you don't really need to write that. But again, if you need to, if it helps you, go right ahead, please do. I'd rather you got it right than you skipped steps that are helpful for you. So I get 5x times x squared. That gets me 5x squared. 5x times 2x is 10. Oh, I did that again. This is cubed. I'm sorry. And that's going to be 10x squared, and 5x times 1 is just plus 5x. And then I'm going to do the 2 times x squared. That's 2x squared. And 2 times 2x is plus 4x. And 2 times 1 is plus 2. And now we're going to collect our like terms. So I've got 5x cubed. And then I've got 10x squared plus 2x squared. That gets me 12x squared. Underline them so I know I've used them up. 5x plus 4x is plus 9x. And then plus 2. Okay, yay, we've got the same thing both ways. Also notice that I got six terms in this line, and that's the same 6 terms I have in this line. Okay, you're welcome to use the diagram when you are learning to do this and to make it make sense in your head. But of course, as the math gets harder as you get on in math, you're not going to want to be doing that. You're going to want to just do it algebraically, symbolically like this, because there's not going to be enough space on your papers. And it's kind of like, when you start doing multiplication, you add it up that many times, but then eventually you just know that 5 times 3 is 15 instead of having to go 5 plus 5 plus 5. Okay, I hope that made sense. Okay, more of the same, expand and simplify. So we get x squared plus 2x cubed is going to be 2x to the 5. And then x squared times x is just x cubed, and 2x times negative 5 is negative 5x. And then we're down the bottom, we get negative 8x cubed, and then minus 4x, and then plus 20. So watch your signs, because this one's minus 4 times minus 5, which is plus 20. And then we're going to collect like terms. So I've got 2x to the 5. X cubed minus 8x cubed is minus 7x cubed. And then minus 9x plus 20. 5x, 4x, and 20. I missed something. Yes, did I? Yes, I did miss something. This was supposed to be 5x squared. See, this is why I'm always encouraging you to check your answers. Okay, actually, you know what? Let's just pretend that I didn't catch that. Let's check this answer. Okay, and we're going to check it with x equals 2 because we don't want to use x equals 1 when we've got squares and cubes in here. Okay, actually, I should do it that way. Let's check it with x. No, let's do it afterwards with x equals 1 because I bet you if I check it with x equals 1, it will actually come out as being correct. I think it will. Okay, so x squared is 4 minus 4. Okay, so if that's going to be 0, then it doesn't actually matter. We're going to end up with whatever this is, it's going to equal 0. So I don't even need to do anything else. Let's come down here. So I've got 2 times 32 minus 7 times 8 minus 9 times 2 plus 20. And I didn't plan to do this, so I'm going to have to grab my calculator to do this calculation now. So it's going to be 64 minus 7 times 8 minus 18 plus 20, and that equals 10. That means that there's a mistake, okay, because those are supposed to be equal, right? So I'm going to erase that, and then just for fun, I'm going to try this with x equals 0 or x equals 1. Let's just check this with x equals 1. You don't need to write this down, but just watch this, okay? So this is going to be 1 squared, which is 1 minus 4, so that's negative 3, times 2 times 1 is 2 plus 1 minus 5. So that's negative 3 times 3 minus 5 is negative 2, so that equals 6. And down here, anything x to the 1, x to the 1 to the anything is just 1. So this is going to be 2 minus 7 minus 9 plus 20. So 2 minus 7 minus 9 plus 20, that equals 6. So it didn't catch the mistake because I checked it with x equals 1. That was a great example of why you don't use 1 to check your answers if you have any exponents in there. Okay, it is in fact wrong. There is a mistake in there, so I'm just going to erase all. Oops, I didn't want to erase all of that. Oops. Okay, I'm going to erase this. I'm going to erase this. And my mistake is that this was supposed to be 5 squared, minus 5x squared. So actually, I am going to erase this line, and I'm going to. And I erased just my underlines. It's risky. Okay, this had a 5. No, this had a 2. Okay, I think that is, what is this? This is a 5. Okay, sorry about that. I'm having far too much fun. Okay, let's combine some like terms in here. I get 2x to the 5, and then x cubed minus 8x cubed is minus 7x cubed. And then I've got minus 5x squared minus 4x plus 20. And that matches what I have on my paper. If I didn't think I would bore you stupid, I would suggest that we check that using x equals 2, but I'm just going to let that one go for now, okay? Because I'm confident that that one's right. Okay, next one. We're going to do the same thing here. Everything in the first times everything in the second. So we're going to go that and that. So we get 2y squared times negative 6 is negative 12y squared. Nope. I think I should stop and go to bed. Negative 2y times y is it's 2y cubed. 2y squared times y, right. And then it's 2y squared times negative 6, so that's minus 12y squared. And then I'm going to go negative 3y times y and times negative 6. So negative 3 times y times y is negative 3y squared. Negative 3y times negative 6 is negative 18y. It's easier to do this than it is to narrate it. It's the narrating it that's getting me here. And then the negative 7 times both is negative 7y and plus 42. And now I got to collect my like terms. So I've got 2y cubed and minus 15y squared and minus 20. Wait. One of those should have been a positive. Negative 3y. Yeah, this one should have been a plus. I am definitely too tired to be doing this tonight. I am sorry. This is not going to be negative 25. This is going to be 18 minus 7. That's going to be 11y plus 11y plus 42. Okay, but I'm choosing to take my tiredness and my careless errors to represent what you guys are going to do, because you're going to make silly mistakes. You're learning how to do this. You are going to make mistakes. You're going to make calculation errors, and that is why I'm such a big advocate for checking your answers, both when you're doing the practice work and also when you're doing the test. So when you're doing the test, you want to check it by substituting in a value for your variable. Okay, it can be anything you want, but we've seen that 1 isn't really useful, and you don't want to use something silly like 312.7. It will work, but it would be a real pain in the neck to do. Don't do that. Okay, last example here, and this one is, this first part is just plain ugly. There's 3 terms here, and one of them is a trinomial. Yee. I'm going to multiply the 4 into here first. So I'm going to have 4a minus 16 times a squared minus 3a minus 6. And then I'm going to be minus something because I have to multiply this together and then subtract the whole thing. This is the difference of squares, so I can shortcut that. That's going to be 16a squared minus 9, right? It's the square of the first term minus the square of the second term. And I'm just going to shut up and write now because I can't narrate and get the right things written down. So I'm just going to write 4a cubed minus 12a squared minus 24a. So that's my 4a times everything. And then minus 16a squared. So much for me shutting up, right? Plus 3 times 16 is 48a, and 6 times 16 is 96. All right, so that's this whole bit here. And then I can do this on this line as well. I can go minus 16a squared plus 9. Okay. And then I'm going to collect my like terms. I have 4a cubed minus 12 minus 16 minus 16. I'm going to get my calculator out for that one. And that gets me minus 44a squared. And then minus 24a plus 48a, that's plus 24a. Plus, and then 96 plus 9, that's plus 105. Okay, and then I'm going to check my value on that. Okay, I have a big red arrow on my notes to point out this one here is a plus because you're subtracting negative 9. Okay, that's all we're going to do for lesson 5. So only do questions 1, 2, 3, and 8 and 9. Okay, don't bother with the ones in the middle. They are doing multiplying 3 binomials, and that's not part of the grade 10 curriculum, and we're just not going to do that because we are, a little pressed for time, and I want to just find as many extra lessons as I can. And the next lesson is on solving problems with polynomial products, and that one is really important that we do. Okay, that's it for this lesson. Have a good time doing the practice work. Bye.